Yes, good morning, students. Now let's move to the next theorem. This is actually lower Reimann integral. This is upper Reimann integral. So I need to prove that this lower Reimann integral is less than or equal to upper Reimann integral. So here let's consider P star to be the common refinement of two partitions P1 and P2. So I can take this P star as P1 union P2. So with no harm, this becomes the common refinement of P1 and P2. Okay, see here P1 is a subset of P star and P2 is a subset of P star if I take P star as P1 union P2. So now P star, which is equal to P1 union P2, will become the common refinement of two partitions P1 and P2. And by previous theorem we have this result. L of P, F, alpha L of P, F, alpha less than or equal to L of P star, F, alpha. I have this. And also I have U of P star, F, alpha less than or equal to U of P2, F, alpha. See here, I can take P1 or P2 because both P1 and P2 are the subset of P star. Or P star is the refinement of P1 and P star is also the refinement of P2. So in place of P1 I can take P2 also. There is no harm in doing that. So L of P1, F, alpha less than or equal to L of P star, F, alpha, or L of P2, F, alpha less than or equal to L of P star, F, alpha. So I can take anything. See here, and U of P star, F, alpha less than or equal to U of P1 or P2. Okay, whatever it is. So we have this result. We have L of P1, F, alpha less than or equal to L of P star, F, alpha, and U of P star, F, alpha less than or equal to U of P2, F, alpha. So by previous theorem you can write this inequality and this inequality. But what about this inequality? See, this also holds automatically because L of P star, F, alpha is 1 minute. See here, L of P star, F, alpha is actually equal to summation small mi delta alpha I equal to 1 to n. Okay, this is your L of P star, F, alpha. And what about U of P star, F, alpha? And that is equal to summation I equal to 1 to n. Instead of small mi, I'll be having capital Mi. And that is delta alpha I. So here we know that this Mi is less than or equal to this capital Mi. Okay. Or also I can say that capital Mi is greater than or equal to this small mi. So these two being with that relation, I can write this is less than or equal to this. Okay. So I have taken this less than or equal to this. And by previous theorem we have this, and we know that any lower sum is less than or equal to upper sum. So here I have used this previous result as well as that result, that is lower sum less than or equal to upper sum. So combining those two will have this inequality. Okay, and from this inequality I can write L of P1, F, alpha less than or equal to U of P2, F, alpha. So I can write this. And one thing you need to note down, in place of P1 I can take P2 also. Okay, if I take P2 also, that will be less than or equal to U of P2, F, alpha. Or if I take P1 also, that will be less than or equal to U of P2, F, alpha. Why? Because here in place of P2 I can write P1. Because P star, U of P star less than U of P1, and also U of P star less than or equal to U of P2. And here in place of P1 I can write P2 because L of P2 is less than or equal to L of P star. Okay, so by at last I will have this. This is less than or equal to this. And in place of P1 I can write P2, or here in place of P2 I can write P1. So if I can write P1 or P2, then I can take Okay, and also instead of P2 I can write P1. Then I can take infimum of this. Okay, see, by doing that, taking infimum here and taking supremum here, I will get the Reimann, lower Reimann integral here and upper Reimann integral here. And if I do that also, if I take supremum here and infimum here, also this inequality holds. Why? Because this is true. This inequality is true for every partition. It is true for P1 as well as P2. It is true for P2 as well as P1. So I can take infimum of that. And here also I can take supremum of that. This will be still true. So if I do like that, I will at last get the lower Riemann integral less than or equal to upper Riemann integral. So thank you.